Welcome back to Wrong Math. Today we're diving deep into the intriguing world of trigonometry to unravel the derivation of the cosine 3x in a geometric way. Join me as we explore the geometric insights that lead us to this fascinating equation. Before we begin, make sure to hit that subscribe button and ring the notification bell so you never miss out on our math explorations. Alright, let's start with the basics. Imagine a unit circle, a circle with a radius of 1 unit. If we have an angle of 3x within this circle, the opposite side of the angle represents sine 3x, and the adjacent side represents cosine 3x. The cosine 3x equation relates the cosine of an angle 3x to the cosine of a single angle x. To visualize this, we can break down the cosine 3x triangle into 3 smaller right triangles, each with an angle of x. These triangles stack on top of each other to form the 3x angle, and in each triangle the opposite side is sine x, and the adjacent side is cosine x. We're going to geometrically derive this equation by resizing the bottom cosine x side using these 3 triangles. Our goal is to make it fit perfectly into the cosine 3x side, proving the equation. Let's start with the bottom triangle. We can move the sine x side to the left so that it aligns with the bottom vertex of the second triangle. To find the resized length of the bottom cosine x side, we compare the ratios of the hypotenuse in the 2 similar triangles and equate them to the ratios of the adjacent sides, revealing that the resized length is cosine x times cosine x. Now, let's move to the second triangle. The sine x side here is slanted, and we need its horizontal component. To find that, we'll determine the angle at the second triangle's top vertex in terms of x. Using alternate angles and the fact that the angles in a triangle add up to 180 degrees, we find that the angle is x. The horizontal component we need is the sine x component of the sine x side, which has a length of sine x times sine x. By moving this part downward and subtracting it from the resized cosine x part, we reduce the cosine x part further to represent the cosine of a 2x triangle with a length of cos squared x minus sine squared x. Using the same process explained before, we can again shift the sine side to the bottom vertex of the third triangle, and using similar triangles, we will get its length to be cos squared x minus sin squared x times cosine x. The sine x side of the third triangle is slanted, and its horizontal component can be obtained by figuring out the angle of the top vertex by using a similar process as before of finding the angles with the help of alternate angles and the sum of angles in a triangle method. We would get that the top angle of the third triangle is 2x, and the horizontal component of the sine x side would be sine x times sine 2x. By moving and subtracting the horizontal component, we eventually end up with a length that perfectly matches the cosine component of the 3x angle triangle. Our equation isn't in the desired form, as it includes sine factors. We substitute sine 2x with 2 times sine x times cosine x, and simplify further by replacing sin squared x with 1 minus cos squared x. And there you have it. We've journeyed through the geometric steps to derive the cosine 3x equation. I hope you enjoyed this video and learned something new. If you did, please give it a thumbs up and subscribe to my channel for more math videos. Stay curious, and I'll see you in the next video.